Hi, and welcome back. I'm Hank Preston, a developer evangelist with Cisco DevNet, and today I'd like to talk to you about Ansible Part 3, Your Network as Code. This is a lesson in our Network Programmability Basics video course, and we are in the Net DevOps module. Inside of this module, we've already talked about configuration management in the network, as well as introduced Ansible and Ansible for network configurations in Part 1 and Part 2. In this lesson, we're actually going to look at how we can use the concepts we've seen to deploy, manage, and configure our entire network configuration as code. Now, if you'd like to follow along with me, please do. Up on GitHub at github.com/ciscodevnet/netprog_basics, you can access all of the code and examples for this lab and everything inside of the video course. Every lab includes a README that has the details on how to prepare your own environment, your laptop, so that you can run these code and exercises. We also have details on which DevNet sandboxes you want to reserve so that you can run these examples with me. Now, in this lesson, we're going to start out with exactly understanding what is infrastructure as code, and then moreover, how does that apply to network as code? Well then, with that under our belts, we'll talk about our network intent, what it is we're trying to accomplish inside of this demo for our network configuration. Once we have an idea of and a good understanding of what our goal is, we'll look at how we can take that intent and make it network as code using Ansible. Finally, we'll make it happen. We'll run our network playbooks and get our entire network configured using Ansible in a modern DevOps fashion. So first, infrastructure as code. We've all heard it, but what exactly does that mean, and how does it relate to us in the network space? We'll start with some definitions. Courtesy of Wikipedia, infrastructure as code is the process of managing and provisioning computer data centers through machine-readable definition files. What that means is, rather than targeting the actual configuration interfaces, the GUIs, exports from actual hardware systems, we're going to use code snippets, things that can be read in by scripts and automation utilities to deploy the configuration, rather than having us as the humans manually configuring them through the interfaces. So in the network, this relates to some principles. We're going to store our network configuration in source control systems, such as Git. We're going to use machine-readable formats such as YAML, JSON, and XML, these data formats that are very easy to script and program against. We'll treat our source control as the single source of truth, whether we're talking about our development instances of our network, our test networks, or production networks. All of them should be configured from that exact same code base, that same source system in our source control. And then finally, we should only deploy our configurations using the programmatic APIs and tooling, such as Ansible. We want to limit manual network configuration because that'll result in configuration drift and get us away from the core concept of infrastructure as code. Now, what exactly is our network intent? In this demonstration, we want to show how we can actually configure an entire network using network as code in Ansible. So our starting topology is this. It's a fairly typical core distribution access network. Our core is made up of iOS XE routers, and our distribution and access are NXOS switches. Now, this network has already been cabled, as indicated on the slide here. And we do have management access into the management interfaces from all these devices, but no other configuration is completed. It's simply cabled, and I have management access to it. Now, what we're trying to accomplish using our network as code principles is this. Between our core and distribution, we want to have layer 3 links with OSPF area 0 routing configured. In our distribution area, we want to configure a VPC topology between our distribution switches, which will enable layer 2 port channels down to the access layer. We'll have a set of VLANs configured and HSRP deployed at the distribution layer to provide access across all of those VLANs for host endpoints. With this in mind, let's talk about how we convert that intent, we convert that topology into code using Ansible. Now, we're going to leverage all of our Ansible mastery we've seen and we've built from Part 1 and Part 2. We'll leverage inventory files for our list of network devices in our topology, and we're going to logically group them for configuration elements. We'll use host and group variable files so that we can define device-specific details, IP information for a device, routing information specific to a device will all go into host files, while we'll use group files across distribution or access or core for things that are common across every device in a particular group. Now for actually building the automation for all of the features and elements necessary, we'll use Ansible roles, and those roles will align to the different network roles that are part of our topology. And then finally, our Ansible playbook will provide our orchestration to deploy the entire network intent across the entire environment. So starting out with our inventory file, here we can see the inventory file we'll use. I have groups in there for core, distribution, and access, as well as groups that identify specific network operating systems when I have configuration or preparation information that applies specifically to all devices of a particular OS. We're setting global configuration variables here in the all vars section of the inventory file, and in this case we're using that trick that we talked about already about Ansible to make sure that our Python interpreter aligns to our virtual environment. So we're using the version of Ansible and all the libraries that we intend. Now moving on into our host variable files, here's where we find the device-specific configuration details. For example, here for our routing configurations, we can see the OSPF router ID for a device. We can see the VPC keep alive details at our distribution layer. And then all of the layer 3 interfaces necessary, both loopbacks, Ethernet, as well as VLAN interfaces that are required. Now, as we go ongoing and we need to update our network configuration, we don't go back into the configuration or the code or even the CLI or any of those. We simply update details inside of these variable files. For example, if we need to add an additional layer 3 interface, we would simply add it to the list that's stored here in the device, the host variable file for this device. For group variables, or things that are consistent across an entire group, so distribution as a group for an example, we can apply those inside of these group variable files. So here we can see our HSRP configuration. That'll be the same on all the distribution switches. OSPF general details and how we'll go through on that, as well as trunk port details because we want consistency. All of our distribution switches should be using the exact same port channels and then members so that we've got good consistency across the network. Now, just like inside of the host configurations, if we need to add additional port channels or make changes to the VPC configuration, maybe an additional member port into that, we simply add it to these lists inside of the group variable files. We don't have to worry about the actual playbooks that are doing the automation. That's part of this division of labor between what you're trying to accomplish and then the environment-specific details that we can do in these variable files. Now finally, we do have some details that are consistent across the entire network, and we can use the all group variable file to store those. In this case, we can see the VLANs list, where all of our VLANs are identified. And in this case, if we need to add a VLAN, again, we just add it to this all VLANs list that goes through. We don't need to go into the configuration details that are there. Now we'll use Ansible roles for all of the feature and the specific configurations. Now the value of roles are that these are reusable across different environments. So I've got roles to enable protocols like netconf or NXAPI for programmatic interfaces or programmatic access. We create roles to be able to use netconf to deploy layer 3 interfaces or use NXAPI with NXOS to configure VPCs. These roles are not tied to our environment or our topology. Once we've written these and tested them, they can be used across multiple different networks and environments. Different data centers can use the exact same roles because we combine the roles with those variable files to make sure that they're environment specific. Now an example of what a role might look like is here. This is where we actually see the automation on how to accomplish some task. In this example, we're seeing how we can use netconf to do interface configuration. Now we're leveraging Jinja templates, and we talked some about those in previous lessons, to actually build the netconf payload that configures an interface that goes through there. And then we use the netconf config module to push that configuration out. Now once this is written, I now have a netconf or an Ansible role that can do interface configuration with netconf, and it's consistent and it works. I don't have to go back into this often. I test it once and now it's a reusable role. We combine the roles together inside of our playbooks where we actually walk through the orchestration of what we're trying to accomplish. Here in our playbook for deploying our network, the first step is to enable the relevant APIs in the environment. So I can see that I have two plays. The first one targets all of the iOS XE devices and enables MDP, or model-driven programmability, netconf and Yang. Our second play targets NXAPI and enables that across my NXOS devices, using a role for that. Now once those APIs are configured, in part 2 we can start to deploy the actual network configuration. So here we have a play that configures the network core and leverages the roles that we've seen. So our network core needs layer 3 interfaces configured and OSPF turned on. This is all that's necessary to bring in the role information and combine it with the variable files we've seen. Now here in part 3, we do the same thing for distribution and access layer. We have a play for the distribution layer, which assigns the roles for VLANs, VPCs, layer 3 interfaces, HSRP, and OSPF. While in our access layer, they need the roles for the VLANs, layer 3 interfaces, these are for management, loopbacks and things like that, and then finally the port channel trunks that uplink the access switch into the distribution layer. Now one of the things that's nice about Ansible is this idempotent behavior. This means I can rerun these playbooks at any time to verify that the configuration still matches what I desire. If I add interfaces, VLANs, or networks to variable files, just rerunning the playbook will make sure that the configuration that's live matches the desired state as laid out in our network as code. If I add new switches, we add them to the inventory file, rerun the playbook, and once again our network is back into spec with our desired state. Now we only have to update the playbooks or the roles when new features are added or changed inside of our network intent. Now that we've talked about what we're trying to accomplish and how we will do it, let's make it happen seeing these playbooks in action. Now before we run the demo, a couple of things to consider when you run this on your own. Now the backend network for this demonstration is being provided by Cisco's Viral. Viral is a great network simulation tool that many people use for learning, but for me the most exciting part about Viral is its power for net DevOps configuration and testing. When we start to move towards infrastructure as code and network as code, tools like Viral give us an ability to spin up test networks that match our production deployments very closely so that we can actually verify our configuration works as desired. Now because we're using Viral and running these across VPNs and leveraging the DevNet sandbox, you may find occasional timeouts when running the Ansible playbooks for some of the devices. This will happen occasionally, not all the time, and the devices that time out may change from one run to another. This is expected behavior. Just simply rerun the playbook and you should catch it up on the next time. Now as you go through, feel free to use options to run the playbooks against a subset of devices for testing. So Ansible playbook -- limit core would target just the core devices, or -- limit distribution just for the distribution devices. And this is a great way to retarget a specific set of devices. Now with this in mind, let's jump into the demo and see how this runs and works. All right, let's jump in and do this demo. To start out with, let's remind ourselves where we're coming from. We have a network cabled like this. We have 2 iOS devices acting as core, 2 NXOS for distribution, and 1 NXOS as access. Each of these devices has management access provided, but no configuration done. Our target state is here. We'll have OSPF and routing configured between distribution and access, and then VPC and port channels going down to from distribution to access. We've got our VLANs configured here so that we'll have a full set of VLANs for topology. All right, so to do this, we're going to run our Ansible playbooks, but let's verify that we don't indeed have configuration done. So here's our first iOS device, so we'll do show run, and we'll just look for OSPF configuration. And indeed, there isn't any. If we look at our second iOS device, we'll do show IP interface brief, and we indeed don't have any interfaces configured other than the management interface that's there. On our first distribution switch, show run VPC, well, we get an error. VPC is not even enabled yet on this device. We'll do the same thing with show IP. On our second distribution switch, show IP interface brief. Again, only a loopback address configured there. And then our access switch, show VLAN brief. And the only thing we have showing there currently is our default VLAN of VLAN 1. So now that we've seen that that's there, let's go ahead and run our Ansible playbook. So to do that, we'll do Ansible playbook, and then network deploy.yaml. This will go ahead and run against all of our network devices. All right, while this runs, we'll be back in just a few minutes when this finishes up and take a look at as it's done. All right, welcome back. So while we had the video paused, I let the playbook continue to run, and now it's finished. So let's take a look at what we see. We can see as we kicked off and started, as we talked about, the first step was to configure netconf, and then to enable NX API. Now once the protocols were set up, we moved into the areas where we configured the network policies. So here we can see the play to configure the network core. That begins with generating the interface configurations using Jinja and the netconf templates, and that's this section here is where the configurations were all generated. And then they're pushed out into the device here where we're configuring network interfaces with netconf. It does the same thing for OSPF in the core, and then moves into the distribution switches. Now one of the things to notice here as we look at the distribution switches is in the output from the tasks. So in this example here, when we look at it, we can see NXOS VPC, that's the role, and then each role may have many tasks involved. So to successfully enable VPC, first we enable the features, then it configures VPC, then it creates the port channel for the VPC peer link, and then configures the other elements that go through. So we can see all of the bits that are composed as part of the roles. In this area, I'm scrolling down, we can see all of the elements for the distribution that gets configured, and then eventually it moves into the access layer to configure the access switches for the configuration that goes through. Now that we've seen the playbook went through, let's actually go and check and see if it affected our switches and our network as we expected. So here on our first of our core switches, we'll do a show IP interface brief. And we can see indeed we now do have configuration on gigabit 2, 3, and 4 that act as those layer 3 links to the other devices. Over on core switch 2, we'll do a show IP route OSPF to see that we are getting OSPF routes across the network that represent all of the routing and layer 3 information across our topology. At the distribution layer, let's see if our VPCs are up and built correctly. So we'll do a show VPC. We can see that we do indeed have our peer adjacency formed, our peer is alive, and we have our peer link is currently up and active, and we have a port channel, and that port channel goes down to our access switch. We can also look at show HSRP brief, and we can see that we've got our routing configuration for each of our VLANs set up appropriately as well. On the second distribution switch, we'll see that we've got our VLANs configured. And our VLANs are indeed configured for our 4 networks that were set up. And then finally on our access switch, we'll just double check that we have our port channel up and functioning to our distribution layer. And indeed it is. Our port channel is up. Port channel 11 is up and functioning on that side. So here we've actually gone and we've been able to configure and deploy using network as code concepts our entire desired network configuration. As a reminder, here's what we were able to build. We started from a completely unconfigured network and got both layer 2 and layer 3 across iOS and NXOS platforms using Ansible in a repeatable fashion. Excellent. So now we've seen and talked about how network as code could function and seen it in action using the live demos that are here. It was pretty exciting. So what did we run through inside of this lesson? We considered what infrastructure as code means and then how that impacts as we go into network as code. We developed an intent for our typical core distribution access network using common standards and platforms that you probably have in your own environment. We then leveraged Ansible to turn that network intent into code and then deployed that configuration to a blank network and seen how easy it was to manage this as we go through. Now please, if you did not run these exercises with me, pause the video, ran them then, do them before you move on. Make sure to see how easy it is to work with these tools in a programmatic fashion. And though this lesson is the end of the Network Programmability Basics course, if you've been jumping around, be sure to go back and catch the earlier videos. There's a lot of good information across this entire course. Lastly, you have to join DevNet. We have so much more available in our learning labs and sandboxes that are out there. If you have questions about this video or anything else in your journey about network programmability, feel free to come find me. I'm hapresto@cisco.com via email or Cisco Spark, and hfpreston up on Twitter. On GitHub, you can reach me at hpreston. And also be sure to follow Cisco DevNet across all the social medias. We're Cisco DevNet on Twitter, Facebook, GitHub, Instagram, all over the place. Thank you so much for joining me for this lesson and the entire video course. We'll see you next time.